Welcome to solverfy.
We have to find the empirical formula for the following situation. So in order to find the empirical formula, we just need to find out the number of moles of each element in the formula, and then we're going to find the simplest ratio between them. Okay, so for A, we have 0.039 mole of iron, and then we have 0.052 of oxygen. So we know that it contains iron and oxygen, but we just don't know the number from the empirical formula. So we're going to find the simplest ratio between two number of moles. Okay, so we can see a ratio over here. We just need to divide the whole ratio by the smallest number, and we should be able to find this roughly around 1.33. Again, we cannot we must have a whole number. We can't have a fraction for our in our formula. So therefore, it's roughly around 1.11 to 1.33. But we will round down that to the nearest whole number, so we're 1.1. So the empirical formula will be Fe1O1. Okay, so for the second scenario, we have 0.903 gram of phosphor, 6.99 gram of bromine. We are going to convert that to number of moles first. So phosphor, we will have 0.903 divided by 30.97 gram per mole. And then we will have roughly around 0.0292 mole. Okay, so for bromine, we have 6.99 gram of bromine, and the bromine molar mass is 79.9 gram per mole. So we have 0.0875 moles. Okay, so we are going to find the ratio between them. Again, we are going to take the divide everything by the smallest number. And then we should be able to find as a roughly around 1 to 2, put 2.99, so 1.3. So the empirical formula will be PbR3. Okay, so for the last one, we have hydrocarbon with 79.9% carbon by mass. Okay, so because we are looking at percentage, and we know that 100% is the the highest percentage, so we can assume we have 100 gram. So we can make a calculation easier. So we have 79.9 gram of carbon. Because we are hydrocarbon means it contains carbon and hydrogen. So therefore, we will have 20.01 grams of hydrogen because we assume we have 100 grams of our hydrocarbons. Okay, so again, we are going to convert that to number of moles. So we're 79 divided by 12. So we have roughly around 6.66 moles. And then for the number of moles of oxygen, we have 20.1 divided by 1. So we have around 20.1. Okay, so we are going to divide the whole thing by the simplest, the smallest number to have the simplest ratio. So we roughly have 1 to 3.01 or around 1 to 3 for the simplest ratio. So that's why we have CH3 as the empirical formula.